Good morning, everyone. This is B. Ramarao from Government Polytechnic College, Station Ganpur. Today, our topic Bronsted Lowery acid base theory. Bronsted Lowery acid base theory. This topic belongs to first year diploma student, first semester, common syllabus, subject code SC104. Topic Bronsted Lowery acid base theory. Last class already we discussed about RNase acid base theory. Now we discuss Bronsted Lowery acid base theory. Bronsted Lowery acid base theory. Objectives. On the completion of this period, you would be able to know. On the completion of this period, you would be able to know. Understand the Bronsted-Lowery concept of acid and bases. Understand the concept of Bronsted-Lowery acid bases. After the completed of this period, you would be able to know. Understand the Bronsted-Lowery concept of acid and bases. What is Bronsted acid? What is Bronsted base? Bronsted-Lowery neutralization, strength of acids and bases, and limitations of Bronsted-Lowery acid-base theory. So, already we discussed about Arrhenius acid-base theory. According to Arrhenius theory, the substance completely or partially dissociated in aqueous solution and produce H plus ions or OH minus ions, then it is act as acid or base. The substance which produce H plus ions is called acid, like HCl, H2SO4, so on. The substance dissociated in aqueous solution it produce OH minus ions is called base, like NaOH, KOH, so on. The acid and base react together to form salt and water is called Arrhenius neutralization. Now, Bronsted-Lowery theory to explain non-aqueous compounds. What is non-aqueous? In order to over the limitations of Arrhenius theory. Arrhenius limitations are it is applicable to only aqueous solution. Some compounds without H plus ions it is act as acids like CO2, SO2, and NO2. Some compounds without NaOH it is act as bases. Those compounds nature cannot explain according to Arrhenius theory. So these overcome two limitations of Arrhenius theory to explain Bronsted-Lowery acid-base theory. In order to overcome the limitations of Arrhenius theory, Bronsted, Denmark, and Lowery, England, in 1923, independently and simultaneously proposed a new theory of acid and bases. According to this theory, proton donor is an acid and proton acceptor is called base. So this theory is also called proton theory. This theory depends on only proton. Proton means H plus ion. Recap. according to Arrhenius theory, substance which gives H plus ions when dissolved in H2O is called acid. What is acid according to Arrhenius theory? The substance which dissociated in aqueous solution and gives H plus ions are called acid, like HCl, H2SO4, HNO3, CH3COH, H2CO3. These all are acids. The substance which gives H plus ions when dissolved in H2O is called acids. What is base? The substance which gives hydroxyl ions when dissolved in H2O is called base. According to Arrhenius base. What is a base? Base is a substance that ionizes in water, produce OH- ions is called base, like NaOH, KOH, magnesium hydroxide, ammonium hydroxide, aluminum hydroxide, calcium hydroxide, zinc hydroxide. These all are bases. The substance which dissociated in aqueous solution it produces OH- ions is called base. So, according to Arrhenius theory, the substance which gives H plus ions in aqueous solution is called acid. The substance which gives OH- ions in aqueous solution is called base. Now, Bronsted-Lowery concept. Bronsted-Lowery concept. According to this concept, acid Bronsted-Lowery acid. Acid are the species capable of donating the proton in a reaction is called Bronsted-Lowery acid. What is acid? A substance which donates a proton to other substance is called acid. What is acid? A substance which can donate a proton to other substance is called an acid. Acids are the species capable of donating the proton in a reaction is called Bronsted-Lowery acid. Proton donors are called Bronsted-Lowery acids. What is protons? Photogenic components like H plus ions which gives are called Bronsted-Lowery acids. Bronsted-Lowery acids. Bronsted-Lowery acids compounds are proton donate to other substance in that reaction is called Bronsted-Lowery acids. Bronsted-Lowery acids proton donating substance. A substance which can donate proton to other substance is called Bronsted-Lowery acid. Proton donor is called acid, like HCl, H2SO4, HNO3, CH3COH, H2O, H3PO4, H2C2O4. These all are Bronsted-Lowery acids. HCl, hydrochloric acid. It donate H plus ion to other substance in a reaction is called Bronsted-Lowery acid. H2SO4, sulfuric acid, HNO3, nitric acid, CH3COH, acetic acid, H2O, water, H3PO4, phosphoric acid. These all are act as Bronsted Lowery acids. Base. What is a base? Base are the species capable of accepting the proton in a reaction is called bases. Base are the species capable of accepting the proton in a reaction that is base. What is a base? Proton acceptors are called Bronsted-Lowery bases. A substance which can accept a proton from other substance is called base. A proton acceptor is called base. Proton acceptor is called base. A substance which can accept a proton from other substance is called Bronsted-Lowery bases. Proton acceptor is called base. Like example, NH3, H2O, HCO3 minus, Cl minus, HSO4 minus, SO4 minus 2, NO3 minus, OH minus, CH3CO minus. These all are proton acceptor. This proton acceptor is called Bronsted-Lowery base. A substance which can accept a proton from other substance is called base. Proton acceptor is called base. Like example, NH3, H2O, HCO3 minus, Cl minus, SO4 minus 2. Here given one example, HCl acid, H2O base, then form H3O plus Cl minus. In this reaction, HCl proton donate to the water molecule, then HCl act as acid. In this reaction, water molecule proton donate to the HCl, proton accepting to the HCl molecule, then form H3O plus Cl minus, H3O plus acid, Cl minus base. HCl acid, H2O base. HCl act as proton donor, H2O proton acceptor, then form H3O plus Cl minus. Then proton donate to the HCl, then form Cl minus. This HCl act as acid before the reaction. When it is involving reaction to form Cl minus ion is act as base. Then this acid molecule convert to the base. Same way, H2O in the reaction, proton accept from HCl molecule. This H2O act as proton acceptor. This proton acceptor, according to Bronsted-Lowery theory, it is act as base. Then it is proton receiving from HCl molecule, then form H3O plus molecule. This H3O plus act as acid. So before reaction, the acid, after reaction it convert to the base. Base convert to the acid. So in Bronsted-Lowery theory, we have two acids and two bases are available. The acid convert to the base convert to the final acid. See another reaction. CH3COOH plus H2O gives H3O plus CH3COO minus. CH3COH plus H2 gives H3O plus CH3COO minus. CH3COH proton donate to the water molecule. These CH3COH act as acid. This H2O molecule accept a proton from acetic acid. These H2O molecule act as base. Similarly, CO2 react with H2O, then form H3O plus HCO3 minus. HCO3 minus. In this reaction, H2O convert to H3O plus HCO2 convert HCO3 minus. NH4 plus H2O gives H3O plus NH3 minus. NH4 proton donate to H2O, then form NH4 act as acid. H2O molecule proton accept from NH4 plus, then act as base. HSO4 minus, then form H2O react together, then form H3O plus SO4 minus 2. These SO4 act as Bronsted Lowery acid, H2 act as Bronsted Lowery base. Similarly, CO2 act as Bronsted Lowery acid, H2 act as Bronsted Lowery base. H2O can act as both an acid and bases. H2O can act as both an acid and bases. H2O is amphiprotic molecule. Amphiprotic molecule. H2O, when it is act as acid, it loss of OH minus ions, then form OH minus. H2O in it is act as base to form H3O plus. H2O in the reaction it is act as acid, then it convert to the OH minus. OH minus act as base. H2O in case of base, then it is convert to the H2O plus, it is act as acid. So these both characters of acids and base compounds are called amphiprotic molecule. Amphiprotic molecule. The acid and base which differ by a proton are known as conjugate acid-base pair. Conjugate acid-base pair. The acid-base pair differ by one proton is called conjugate acid-base pair. The acid-base pair in the above two reactions HCl, Cl minus, NH3, NH4 plus, H3O plus, H2O, H2O, OH minus ions differ from each other by one proton only. So, all these are conjugate acid-base pair. So, an acid by donating a proton is converted into conjugate base, and a base by accepting a proton, it converts into a conjugate acid. What is conjugate acid base pair? The acid base pair differ by one proton are called conjugate acid base pair. Acid loss of one proton, that means acid minus proton, to form conjugate base. Base gain of proton to form conjugate acid. So here HCl Cl minus conjugate acid base pair, these both pair differ by only one proton, are called conjugate acid base pair. The acid and base which differ by a proton, are known as conjugate acid base pair. CH3COH plus H2O gives H3O plus CH3COO minus. The above reaction involves two conjugate pairs. CH3COH proton donate to the water molecule, then it is act as acid. Then it is after donating proton, it forms CH3CO minus, act as base. One is acid, it converts to the base. The base of H2O gain of proton from acetic acid to form H3O plus. These H3O plus act as acid. So acid CH3COH loss of proton to form CH3CO minus base. These H3O CH3COO minus gain of proton to form CH3COH. Similarly, see another reaction, H2O loss of proton to form H2O. When it is act as base, proton accept from other substance, then form H3O plus, act as acid. The H3O plus loss of proton, then form H2O. Some conjugate acid base pairs. An acid by donating a proton is converted into conjugate base, and a base by accepting a proton is converted into conjugate acid. Acid conjugate base HNO3, its conjugate base NO3 minus. H2SO4, its conjugate base HSO4 minus. H2O, its conjugate base OH minus ion. CH3COH, conjugate base CH3CO minus. NH4 plus, its conjugate base NH3. HCl, its conjugate base Cl minus. NH3, its conjugate base NH2 minus. H3PO2, its conjugate base H2PO2 minus. Acid and its conjugate base. HNO3, its conjugate base NO3 minus. H2SO4, its conjugate base HSO4 minus. H2O, its conjugate base OH minus. CH3COH, acetic acid, its conjugate base CH3CO minus. NH4 plus, its conjugate base NH3. HCl, conjugate base Cl minus. NH3, its conjugate base NH2 minus. H3PO2, its conjugate base H2PO2 minus. Strength of acid. Strength of acid. Ha plus H2O gives H3O plus A minus. Like HCl react with H2O to form H3O plus Cl minus. Similarly, any acidic molecule of Ha. So, constant of Ka is equal H3O plus concentration A minus concentration by Ha concentration. Ka equilibrium constant of acid. Ka equilibrium constant of acid. Strength of acid. Strength of acid. An acid which has great tendency to donate a proton is called strong acid. An acid which has great tendency to donate a proton. An acid which has great tendency to donate a proton is called strong acid. An acid which has less tendency to donate a proton is called weak acid. Strong acid, weak acid. What is strong acid? A substance which has greater tendency to donate a proton is called strong acid. Like example, strong acids HCl, H2SO4, HNO3, so on. An acid which has less tendency to donate a proton is called weak acid. A substance which has less tendency to donate a proton is called weak acid. Like weak acids, example CH3COH, HCOH, H2CO3, HCN, so on. Strong acid, weak acid. An acid which has greater tendency to donate a proton is called strong acid, like HCl. An acid which has less tendency to donate a proton is called weak acid, like example CH3COOH. Strength of base. BOH gives BH plus OH minus. Here H2O acts as acid by donating of H plus ions to B. Kb is equal BH plus concentration into OH minus ion concentration by B concentration. Kb is equal equilibrium constant of base. Equilibrium constant of base. Strength of base. A base which has more tendency to accept a proton is called strong base. A substance which has a greater tendency to accept a proton is called strong base. Like strong bases CH3CO minus, OH minus, Cn minus, HCO3 minus, so on. Weak base. A substance which has less tendency to accept a proton is called weak base. A substance which has less tendency to accept a proton is called weak base. Weak base, like example Cl minus, ClO4 minus, HSO4 minus, HSO4 minus. So here Bronsted Lowery theory in 1923. According to RNS theory, it is explained in 1887. The Bronsted theory was proposed in 1923. The Bronsted, a Danish chemistry, and Thomas Lowery, an English chemist, proposed a new definition of acids and bases. Those both are given a new definition between acid and base. What are the definition? It depends only proton. See here, Bronsted-Lowery theory. Bronsted and Lowery had worked independently of each other, but they both arrived at the same definition. An acid is a substance that donates proton. A base is a substance that accepts a proton. Proton donor and proton acceptor. An acid is a substance that donates proton, like HCl, H2SO4, HNO3, CH3COH. These all are proton donate to other substance is act as Bronsted-Lowery acids. What is base? A base is a substance that accepts proton, like NH3, H2O, HCO3 minus, Cl minus, SO4 minus 2. Bronsted-Lowery acid and base. See here one reaction. HCl plus H2O then form H3O plus Cl minus. H2O, when proton donate to H2O molecule, so then form these HCl molecule convert to the Cl minus. The HCl proton donate to water molecule, these HCl act as acid. By the transfer of proton from HCl, then form Cl minus act as base. Similarly, the H2O molecule before the reaction it is act as Bronsted-Lowery base. After proton accept from HCl then form H3O plus these molecules act as acid. So in this reaction two acids and two bases are possible. The HCl donate a proton and so is an acid. The H2O in this case accept a proton and so is proton. Acceptor is called Bronsted-Lowery base. So another reaction HNO3 plus H2O gives H3O plus NO3 minus. NO3 minus. HNO3 plus H2O to form H3O plus NO3 minus. These H1O3 in this reaction proton donate to water molecule. These compound act as Bronsted-Lowery acid. H2O molecule proton accept from other substance in this reaction is called Bronsted-Lowery base. This base after proton accept then form H3O plus this compound act as acid. NO3 minus base. See another reaction H2SO4 plus H2O gives H3O plus HSO4 minus. So HSO4 is act as Bronsted Lowery acid. These H2O molecule act as Bronsted Lowery base. These H2SO4 minus remaining react with water molecule, then form SO4 minus 2 H3O plus. These HSO4 minus act as Bronsted Lowery acid, SO4 minus 2 base, H3O base, H3O plus acid. What is a base? Proton acceptor is called base. NH3 plus H2O gives NH4 plus OH minus. The NH3 accepts a proton and so is called base. The H2O in this case donate a proton and so is an acid. Amphoteric molecule. Amphiprotic molecule. As can be seen from the previous two examples, water is capable of acting as both an acid and basis. Any substance that can act as both an acid and a base is said to be amphoteric acid, amphoteric molecule. What is amphoteric? As can be seen from the previous two examples, water is capable of acting as both acid and a base. Any substance that can act as both an acid and a base is said to be amphoteric. Acid-base reaction HCl plus NH3 gives Cl minus NH4 plus. HCl acid then donate a proton from HCl to NH3, then Cl minus act as base. NH3 proton acceptor from HCl, these NH3 molecule act as base. After proton accept, then form NH4 plus act as acid. Acid proton donate to proton donor. Base accept protons. Conjugate acid base pair. Acid and bases exist in the pair is called conjugate acid base pair. Every time an acid donates or loses a proton, it becomes its conjugate base. CH3COH plus H2O gives CH3CO minus plus H3O plus. Acid and base exist in pairs is called conjugate acid base pair. Every time an acid donates or loses a proton, it becomes its conjugate basis. CH3COH plus H2O gives CH3CO minus plus H2O. Likewise, when a base accepts a proton, it becomes its conjugate acid. NH3 base. When a base accepts a proton, it becomes its conjugate acid. NH3 react with H2O, then form NH4 plus OH minus. NH3 acts as base, then after gain of proton from H2O, then form NH4 plus act as acid. H2O molecule in this reaction, proton donate to the NH3, The H2O act as acid, which means act as base. Acid H2SO4 plus H2O base then form conjugate acid base HSO4 minus plus H3O plus. NH3 plus H2S gives NH4 plus HS minus. Summary: acids are proton donors. Acids are proton donors. Bases are proton acceptor. Acids. According to Bronsted Lowery acid, a substance which can donate a proton to other substance is called acid. Acids are proton donors is called acid. Like example, HCl, H2SO4, HNO3, CH3COH, so on. These all are acids. What is base? A substance which can accept a proton from other substance is called Bronsted Lowery base. Proton acceptor is called base. Like NH3, H2O, HCO3 minus, Cl minus, these all are proton acceptor. The acid and base which differ by a proton are known as conjugate acid base pair. What is conjugate acid base pair? Acid and base. A pair of acid and base differ by one proton is called conjugate acid base pair. The acid and base which differ by a proton are known as conjugate acid base pair. Like HCl plus H2O gives H3O plus Cl minus. HCl acid 1, its conjugate base Cl minus. H3O plus acid, its conjugate base H2O. The HCl and Cl minus which differ by only one proton, this pair is called conjugate acid base pair. Summary: an acid which has less tendency to donate a proton is called weak acid. An acid which has less tendency to donate a proton is called weak acid. Less tendency to donate a proton are called weak acids. Weak acids like example CH3COH, HCOH, H2CO3, HCN, so on. An acid which has greater tendency to donate a proton is called strong acid. A substance which has greater tendency to donate proton is called strong acid. Strong acids like HCl, H2SO4, HNO3, so on. A substance which has less tendency to donate a proton is called weak acid. A substance which has greater tendency to donate a proton is called strong acid. A base which has more tendency to accept a proton is called strong base. A base which has less tendency to accept a proton is called strong base. A some less tendency to accept a proton is called weak base. A base which has more tendency to accept a proton is called strong base. Quiz: which is Bronsted Lowery acid? Options: A CO2, B SO2, C NH3, D HCl. What is Bronsted Lowery acid? Proton donate to the other substance or proton donor is called acid. CO2, A, B SO2, C NH3, D HCl. Here A, it does not present any proton, so it does not act as Bronsted Lowery acid. SO2 also same. NH3 donate proton depends on involving substance. Here easily freely gives proton to other substance. HCl is act as Bronsted Lowery acid. Answer is D. CO2, SO2, NH3, HCl. In this four substance, HCl act as Bronsted Lowery acid. Answer D. Bronsted Lowery acid, HCl. Which is Bronsted Lowery base? What is Bronsted Lowery base? Proton accept to other substance is called Bronsted Lowery base. Proton acceptors are called Bronsted Lowery base. Options A, CO2, B, SO2, C, NH3, D, HCl. In these four components, CO2, SO2, HCl does not accept proton from other substance. In this four component, ammonia easily accepts proton from other substance, then it is act as Bronsted Lowery base. Answer C, ammonia. Identify correct conjugate acid base pair. CO2, H2CO3, SO2, H2SO4, NH3, NH2 minus, D, HCl, Cl minus. Identify correct conjugate acid base pair. What is conjugate acid base? A pair of acid and base differ by only one proton is called conjugate acid base pair. Conjugate acid base pair that bear HCl and Cl minus, both C and D. C and D both act as conjugate acid base pair. Frequently asked questions about this topic. Briefly explain Bronsted Lowery theory of acids and bases with example. What is conjugate acid base pair? Example with different examples. Thank you once again.